In this video, we will discuss about certificates. A certificate or a digital certificate is a unique, digitally signed document which authoritatively identifies an individual or an organization. So think of certificate as an identity for a website or for a company. To understand the certificate, first we need to understand different types of encryption here. So we'll see types of encryption. We have symmetric encryption and asymmetric. In symmetric encryption, same key is used to encrypt the traffic and same key is used to decrypt. Let's say we have a sender and a receiver. When A needs to send something to B, he'll use a key and the same key will be used by B to decrypt that data. So let's say A has a data to send 1 to 3. A will use a key, maybe lowercase a, to encrypt this data and send it to B. When B receives this encrypted data, B will use the exact same key, A, to decrypt that and get the real data out of the encrypted text. So they need to find a way to share that key with each other and then basically use that to encrypt and decrypt data. In case of asymmetric encryption, there will be two keys. One key will be used to encrypt the data and another one to decrypt it. So for asymmetric, let's again take the same example. Let's say A and B. A needs to send something to B. So before that, they both need to create a key pair. So A will create a key pair A and XA, where A is the private key of A and XA is the public key of A. B will also create a key pair where lowercase b will be the private key of B and XB is the public key of B. Since the name says private, so B will keep its private key private and never share it with anyone. A will also keep its private key private and does not share it with anyone. The public keys are meant to be shared publicly with anyone. So A can share its public key with B and B can share its public key with A. So both A and B, they will know public key of each other. When A needs to send some data now, so let's say A has some data 1 to 3 that it needs to send to B. So when A needs to send 1 to 3 to B, because it already has a public key of B, so A will encrypt this data using the public key of B and send it to B. When B receives this encrypted data, so B will use its private key to decrypt the data that was encrypted with its public key and get the real data out of that. Similarly, if B needs to send something to A, so B will use A's public key to encrypt this data and send it to A, and then A will use its private key to decrypt that data. So that's asymmetric encryption. Now, how to get a certificate? So to get a certificate, a client needs to first generate something called as a certificate signing request or a CSR. To generate a CSR, the client side will first generate a key pair, a private key and a public key, and then uses its public key to generate the CSR. In the CSR or the certificate signing request, the client will fill information about itself, the website. Important information to be filled in the CSR is common name. What is the URL or the FQDN for your website? That is usually written in the CN name or common name field here. So let's say I'm requesting for a certificate for a website abc.com. So my CN name in this certificate signing request will be abc.com. There can be some other fields as well, like what is your organization, what is the country. So you can provide more details about your website or organization here in the certificate signing request. Once you have this certificate signing request, you need to export this. When you export this certificate signing request, it generates a .csr file. Looking at this format, you will know that it's a certificate signing request and it needs to be sent to a third-party CA or a public CA. The public CA will then sign the certificate signing request. So when you send the CSR to the public CA, they will verify the details given by you and then sign it and give it back to you. So when the public CA signs the CSR, this becomes a public certificate. When you get that public certificate, it will be in .pem format or .cer. So these are the formats for public certificate. This is also known as PKCS 10. So this is how a client is issued a certificate. So CSR, when it is signed by a public certificate authority, that becomes a certificate. Now we'll see types of certificate. So first of all, we have self-signed certificate. Self-signed certificates are like a self-signed identity card where you create your own identity card and you sign it saying that this is who I am, but no one is going to believe that because It is signed by you, created by you, and signed by you. Same thing applies to self-signed certificates. You can create a certificate for your own website. That type of certificate is known as self-signed certificate, where you create it for yourself, which means it is not signed by a trusted root CA or a trusted certificate authority. Certificate will have two important fields. One is issued to. This will tell to whom the certificate has been issued. In this case, maybe let's say I have a website abc.com. So you may have issued to abc.com, and then we'll have issued by. So who issued that certificate? In a self-signed certificate, the issued to and issued by, they both will be same. And then the issued by will not be a trusted CA. So this type of certificates are known as self-signed certificate, where issued to and issued by fields are same, and the issued by is not a trusted CA or not a third-party CA. The next type of certificate is an identity certificate or ID cert. Identity certificates are issued by the public certificate authorities or a third-party certificate authority. The identity certificate can be issued for a website or for an organization, but then issued by will be a trusted root CA. So the ID cert can have issued to abc.com, but then the issued by field in an identity certificate will be a trusted root CA. Maybe could add this type of certificate where it has been issued by a public root CA. They're known as identity certificate. The third type of certificate is a wildcard certificate. A wildcard certificate, as the name says, the common name in that certificate will be wildcard. What does that mean? So it will have star dot your domain name, star.domain.com. This is usually very helpful when you have lots of websites and you need certificate for all of them, but all those websites must match to the same domain. Then you can get yourself a wildcard certificate. The wildcard certificate is very similar to identity certificate. It's just that the CN name will have a wildcard entry for the domain name. So you can use it for any website where it must match the domain. So if you have a website abc.domain.com, you can use this certificate. If you have a website vpn.domain.com, you can use the certificate. So you can have any website which ends with domain.com, and this certificate will be valid there. What if I have multiple domains in my organization and I need certificate for all of them? Or maybe if I have just a couple of URLs and I need certificate for them. So in that case, wildcard certificate will not be the solution. Then we need a different type of certificate, which is known as Multidomain Certificate. It is also known as SAN certificate. SAN stands for Subject Alternative Name, which means with the default CN name of a certificate, it will have some additional fields as well, which will be the subject alternative names. So you can have a CN name in a certificate, abc.com, and then you can have multiple SAN names here or domain names. So you can have multiple domains in the same certificate. This certificate can be valid for abc.com. It can also be valid for vpn.com or abc.vpn.com. So you can have multiple SAN names in the same certificate, and this certificate can be used by any of these websites because it's a multi-domain certificate. Next, we'll talk about certificate authority, also known as CA. So we have a root CA, and then the root CA will have intermediate CA. The root CA has passed on the responsibilities to intermediate CA or delegated the work that you assign the certificates to everyone. Right. So we can have multiple intermediate CAs as well. Now, how do we figure out if that certificate was given by a root CA or an intermediate CA? So let's say we have a root CA whose name is A, and we have an intermediate CA whose name is B. And then there is someone who is requesting for a certificate. So a website, abc.com, is requesting for a certificate. So they created their CSR and sent it to the public authority, which came here to the intermediate CA. The intermediate CA, because it has been given delegation from the root CA that you can issue the certificate. So intermediate CA signed that CSR request that came for abc.com and issued a certificate. So this certificate that was given to abc.com will have an issued to field. So it will be issued to abc.com, and then issued by. There it will have the name of the server who issued that certificate or who signed that certificate. So that is B in this case. So along with that, the intermediate CA will also share the information about root, that who my root is. So it is possible that you might not trust the intermediate CA, so it needs to provide all the details, like all the details about the root as well. So it will tell you that this is my root CA. A is the root. It will not say that exactly in the issued by field, but you'll see that information in your certificate. So basically, when you go to a certificate, you'll click on details. So it will show you the entire path that issued to the abc.com, issued by B, and then I also have a root CA. The root CA issues a certificate to intermediate CA to make sure that intermediate CA is trusted. So the certificate that it gives to the intermediate CA will have issued to B and issued by A. Similarly, the root CA will also have its own certificate in which the issued to field will be A and issued by will also be A. But this A here is a trusted root authority. You might find it very similar to a self-signed certificate, that root CA is using a self-signed certificate, but this is a trusted root authority, trusted certificate authority. So this type of certificate are known as root certificates. But when you have issued to and issued by field same, and which is not a trusted authority, those type of certificates are known as self-signed certificate. And when the same certificate is issued by a root or a trusted certificate authority, so those certificates are known as root. Now finally, we'll see how does a machine validate a server certificate. So when a website presents its certificate to the machine needs to validate if your certificate is trusted by me or not. So to validate that certificate, it looks at the issued by field. Let's say I'm trying to go to a website, abc.com, and abc.com presents a certificate to my machine saying that I am abc.com and I've been given a certificate by GoDaddy. So my computer needs to validate the certificate. Do I trust abc.com? No, I don't know who abc.com is. But do I trust the issuer who gave certificate to abc.com? GoDaddy. So do I trust GoDaddy? So to confirm that, to figure that out, this machine looks at its certificate store. Each computer has its own certificate store where it knows about all the trusted root CAs, and it also knows about the intermediate CAs. So the certificate store already has all the well-known root CAs and well-known intermediate CAs. When it looks at who issued this certificate, GoDaddy, so it goes to the certificate store and checks, do I trust GoDaddy? Is that in my root CA? If yes, I trust you as well. If no, then let me check if it was an intermediate CA who gave you the certificate. It checks the intermediate CA certificates. If the issued by matches there, then I trust abc.com. This is how the machine validates a certificate presented by a website. So let's verify that on the machine level. So I go to the run window and type MMC here. It opens the management console. So you click File, Add, Remove, Snap-in, then select Certificate, click on Add, say My User Account, Finish, and that loads the certificates for you. So you have personal, then you have trusted root certificate authorities. So expand that and click on certificates. This is where you see all the trusted root certificates. Right? And then we also have intermediate certificates. So these are the intermediate CAs. So all the computers, they have this information beforehand. That is all about the certificates.